In this tutorial, I'm going to walk through how we get the conservation of energy and what types of energy there are in a free fall with no air resistance problem using the kinematic equations to show you guys where these kinetic energy and potential energy terms come from and why they're great. So, in this free fall, we're going to have just the y direction. Initially, we have a ball that's falling down with v initial y, velocity at a height y initial. At some time later, it's going to be at y final, and it'll have a larger velocity because it's in free fall, so y final velocity. This is because the only force that's acting is that we have gravity going down, so ay equals negative g. Using our key kinematic equations from before, Vf y squared is equal to Vi y squared plus 2a yf minus yi. I'm now going to plug things in and algebraically rearrange this equation. Vf squared y equals Vi squared y plus, let's just put the minus 2g, because g is downward, y final, plus 2g y initial. So all I did was FOIL out the y final minus y initial term and plugged in g for a. So I want to get things with the suffix final on one side of the equation. So I'm going to move this over by adding it to both sides. So we get Vf y squared plus 2 times g y final equals Vi squared plus y plus 2g y initial. So if you remove the subscripts, this is Vf squared plus 2g y equals Vi squared y final plus 2g y initial. So that means this is a constant value. At any point, you can find the sum of Vf squared plus 2gy, and that will always be the same regardless of what point. This is because of the conservation of energy. So, if we want to get these in the forms that we know, we're going to just do some multiplication. So I'm just going to divide both sides by 2 because it will look nicer. It's 1/2 Vf squared plus gyf equals 1/2 Vi squared plus gyi. So all I did was divide both sides by 2. Now I'm going to multiply both sides by m. So 1/2 mVf squared plus mgyf equals 1/2 mvi squared plus mgyi. So, 1/2 mvf squared, not f, let's just do mv squared plus mgy is a constant value. And this is the law of conservation of energy. So, the energy caused by a velocity of the ball moving, we call that the kinetic energy. So I'm just going to define it, 1/2 mv squared. And the energy caused by a height, we're going to call the potential energy, or gravitational potential energy, and I'm going to give that U mgy. So this is kinetic energy, and this is gravitational potential energy. And these two things will be used in all the problems going forward. So at any point, you just have to find its mass, its velocity in that direction, and its position.